We're doing some trigonometry questions here. And whenever you do a trigonometry question, make sure that you get into the habit of always doing the same sort of method each time. There should be a kind of algorithm that runs through your head when you're doing a trig question. Now there's some steps at the top of this page that I'm following, and I always are thinking this way when I'm doing a trig question. I'll always, when I approach a trig question like this, the first thing I ask myself is which sides are involved. In this triangle, it's the opposite side and adjacent side. The next thing I ask myself is which trig ratio connects together the opposite and adjacent side. Now if I look at my trig ratios, I can see it's the tan ratio. The tan of an angle equals opposite over adjacent. So this is a tan question. The third thing I have to do is I write an equation which uses that trig ratio to connect together the sides in this triangle. For this triangle, it means that the tan of 48 degrees is equal to opposite over adjacent. In this case, it'll be opposite is x and adjacent is 4.2. Now we've got a little equation. We can shuffle it round until we get x equals something. At the moment we've got x divided by 4.2. So if I want to get rid of that 4.2 so that I've got x by itself, that's what I'm trying to get, I'm going to have to multiply this side by 4.2. It's the opposite of operation to dividing. So if I multiply this side by 4.2, I'll be just left with x, but I must also multiply this side by 4.2. 4.2 times the tan of 48 equals x. Now, I can do this on my calculator. I've got the Casio ClassPad 400 up on the screen here. Now, a couple of things. It doesn't matter what brand of calculator that you're using. It's very important to, before you do any trig calculation, to make sure that you've got your calculator set to the correct angle mode. And down the bottom here, there's some different choices here of what you might have, radians. But the most important thing is we're doing these questions and we've got the angle in degrees. You must have that correct no matter what brand of calculator that you're using. So check that before you start. And off we go. We want to do 4.2 times the tan of 48. Now the good thing about these calculators is you can see on the screen that you've got it set up exactly correct. 4.2 times, and we'll have to go to our trig, the tan of 48. And we should get, we'll get 4.66 is the answer, so x is equal to 4.66, and the question was written in centimetres, so that's the units of our answer. Let's do another, and people try and notice that I'm using this kind of algorithmic stepwise approach. The first step, which sides are involved? In this case it's going to be the adjacent and hypotenuse. So I look at my trig ratios and I say which of those three trig ratios is it that connects together the adjacent and hypotenuse? It's the cosine ratio. That means, as far as this question is concerned, the cosine of this angle, the cosine of 37, is equal to the adjacent side, that's x, over the hypotenuse, 14. Now I have to rearrange this to make x the subject. At the moment I've got x divided by 14, so if I times this side by 14, I'll just be left with x. But I also must times this side by 14, so 14 times the cos of 37 will equal x. And now I go to my calculator. 14 times trig functions, the cosine of 37. And the answer is x equals 11.18. Now, one tip that I would recommend to you, these triangles were drawn for me on the page. But if you are in the situation where you have to draw your own diagram, try and make it roughly to some sort of scale. Make your sides in proportion to each other if they've got lengths. Make your angles, maybe if that's 37, make it look like it could be 37. That way, when you get your final answer, you can go back to the question and look at it and say, could that side be 11.18? And if you've drawn it in proportion, you can just kind of say, yes, that's a reasonable sort of answer. Always check too, if you're doing a question where you're working out the hypotenuse, it should be the longest of the sides. Or in the case here, 11.18, it's got to be less than the hypotenuse, and it is. I'm fairly confident then that that answer is correct. Now sometimes when you do a trig question, you end up the situation where x is in the denominator, the bottom of the fraction. Take a look at these examples here. If I do this, the first step is, which sides are involved? Opposite and adjacent. It's another tan question. So the tan of 68 equals opposite over adjacent, 12 over x. It's worked out that x is in the bottom of this fraction. Now the steps involved in transposing it so that x is the subject are quite different here. I'll start off by multiplying both sides by x. So at the moment it's 12 divided by x. If I times that by x, that's going to get rid of that x there, and I'll just be left with 12. But I've times this side by x, so I must also times this side by x. I'll get x times the tan of 68 equals 12. Now I'm trying to get x by itself. I haven't got that yet. All I've got is x times the tan of 68. But remembering that the tan of 68 is just a number, I can divide both sides by the tan of 68. X times tan of 68 divided by tan of 68 will get rid of that. I'll be left with x, but I've also got to divide this side by the tan of 68. So I've divided both sides by the tan of 68, and now I'm ready to do the calculations on my calculator. So it's 12 divided by tan of 68. Let's set it up on the calculator. 12 divided by the tan of 68 degrees. And I get 4.85 to 2 decimal places. Centimetres is the units of my answer. Oh, I've forgotten one over here. There we go. Next example. We've got the sides involved are the opposite and hypotenuse. So I think, which of the three trig ratios connects together opposite and hypotenuse? It's the sine ratio. I can say that the sine of 70 equals opposite over hypotenuse, 7.2 over x. Again, we've got the situation where x is in the denominator of our fraction. So to get it by itself, I'm going to start off by timesing both sides by x. If I times this side by x, I'll be left with 7.2. Times this side by x, and I'll get x times the sine of 70. Not quite what I want yet. I want to get x by itself. I've got x times the sine of 70. If I divide both sides by the sine of 70, I've got x equals 7.2 divided by the sine of 70. Now, I can do that on my calculator. X is equal to 7.2 divided by the sine of 70. That's correct. 7.66. Check my answer looks appropriate. Unit, write the units in. Answer looks appropriate because it's the hypotenuse we've found and it seems to be the longest side, so that's good. Now, you need to be a real expert at this, so I would recommend that you don't skimp on practice of this one.